Okay, can you hear me?
Yes, we can, Boris.
Okay, so good morning and good afternoon, everyone. Welcome and thank you for joining for today's webinar section. This webinar section is part of the cell therapy solution product series in our marketing event. My name is Boris Cheng, the APAC Commercial Manager for Cold Storage Business. Today, I will be the host of the webinar today. Together with me, I have Jean as the moderator, and she will control all the user functions of the event. When you log in, you will be muted by default. If you have any question, any problems, you can type in your questions in the Q&A box, or you can also raise your hand, and then when understand, mute you, and then will be able to ask your questions. Okay, the title of today is Managing Data in Laboratory Equipment, Connectivity Solution, Regulatory Implication, and Quality Control. Laboratory equipment, that means is the ULT freezer, CO2 incubator, BSC, centrifuge, etc. in the laboratory. Also, I would like to introduce the speaker to you, Mr. Joshua Lewis. He is the Senior Product Manager for Remote Monitoring and Connectivity Solution in Laboratory Product Division, Life Science Solution Group. Josh has more than 10 years experience in cold storage equipment, and he's recently targeting his focus on connectivity solution for the whole product portfolio in laboratory equipment. George holds a bachelor degree in mechanical and aerospace engineering from Stanford University, and also the Master of Science in Mechanical Engineering with Fluid Dynamics from Georgia Institute of Technology. So Josh have a lot of experience with our equipments, connectivity, and also remote monitoring. Without further delay, I will pass my time to Josh and start this webinar. Thank you, Josh.
Thank you, Boris, for that introduction. And good morning and good afternoon to everyone on the call today. As Boris mentioned, the purpose of today's discussion will be really looking at our laboratory equipment, but really through the lens of how do we manage that data, both from a kind of a connectivity or how the equipment within the lab connects or talks to one another, but also from a regulatory implication standpoint and really a quality standpoint. We're going to spend a lot of time looking at specifically 21 CFR Part 11 and how we may comply with that regulation, or at least that ID or that standard. And then we're going to look at, a variety of remote monitoring equipment. So as Boris mentioned, if you do have questions throughout the discussion, feel free to put them in the chat window. I know I'm not going to be able to see your hands or the questions while we're giving the discussion, but we are going to have a fair amount of time toward the end of the call for all of the question and answer portion. So with that being said, kind of mentioned it, but just a layout of how our conversation is going to go today. We're going to look at laboratory equipment. Specifically, I'm going to use examples from the Thermo Scientific portfolio, but I'm only doing that as an example, and really the discussion is generic, is meant to be generic across all types of equipment, whether or not they are Thermo branded devices or if they are of a different manufacturer. The intent is really to make an understanding of connections and how we manage and process our data. Then, like I said, we're going to talk a lot about the regulations or the specifics around the FDA's 21 CFR Part 11 protocol. And then finally, we're going to wrap the discussion with looking at embedded versus external remote monitoring systems. So that being said, let's go ahead and dive into our first topic, laboratory equipment. So when we think about laboratory equipment, as Boris mentioned, that can be ultra low temperature freezers, it can be biosafety cabinets, incubators, centrifuges. Almost every piece of equipment that we use in our labs today, they all generate data. Whether that data is temperature or CO2 or alarms, events, there is an abundance of different types of information. And really, it's a matter of one, what is the information and what do we want to do with it? In today's lab equipment, the instruments are getting smarter and smarter. A lot of that information, what used to be very binary in detail, whether that be a simple temperature, or a alarm state, as in you are in alarm or you're not in alarm. I mean, that has progressed with today's equipment. Now we're getting more detailed information around what type of alarm, what type of event. We're getting details around not only the temperatures within, call it the incubator or the refrigerator, but also the system, how the system is performing, so you can better track the diagnostics of the equipment itself. All of this type of data is being generated every second of every day in all of our equipment across the lab. So when we think about all this data, where does it go, right? I mean, it's great that we generate all of these pieces of information, but what are we doing with it? And can we use it? Well, across the industry, there are different forms of data storage. A lot of equipment still use onboard memory. So that would be memory that would be on almost like a computer, right? They store memory on the hard drive. Sometimes that can be either embedded, meaning you can't really extract it without accessing it via software. Other times it can be an external memory card that mounts on the device itself. You can also use USB. And then, of course, in more modern equipment, there is links out to cloud storage. So I guess you may be wondering why I'm touching base on, or why I'm bringing up the types of data storage. But I'm really laying the foundation for understanding how the different types of information go from being generated to stored to transmitted or passed to then to their final historical storage location. All of that we're going to get into detail with regard to 21 CFR compliance. So outside of the storage, we just mentioned the types of data go through a transition. Generation, it gets passed, and then it gets ultimately stored. There are many different types of connection points on laboratory equipment. Some of the more basic connection points being 4 to 20 milliamp or dry contacts. These types of connections are historically the most common when it comes to accessing a single piece of information, whether that be temperature via the 4 to 20, or maybe an alarm state from the dry contacts. What you may not know is that a lot of equipment specifically has a serial port connection, much like the connection you would make to a printer or an older fax machine. That type of serial port connection actually can transmit a multitude of different data points or data pieces from the given equipment. Now, that comes in a variety of types of serial connection. And I will be honest, a lot of manufacturers use that same serial port connection during the manufacturing process. So there are multiple uses for that type of connection. And then in today's smarter equipment, we start to see built-in Wi-Fi or even external monitoring devices that utilize a Wi-Fi connection or a Bluetooth connection. So we no longer have to be hard connected or using physical cables. We have the ability to transmit this data wirelessly to either an on-premise storage server or the cloud environment. So we have a lot of different data being generated. And when we look at some just like some examples of the types of laboratory equipment out there. I just threw a few different examples on the screen to give you an idea of the type of data that, for example, the ultra-low freezers or the refrigerators. I mean, the types of data that we are generating every minute of every day and storing for the life of these products would be, cabinet temperature, ambient temperature, different temperature sensors throughout the device, as well as the different power status or backup systems that you may have it, batteries, alarms, events, and all of the settings. That's a lot of information and a lot of detail. Now, it may not exactly pertain to the samples directly being stored in the device or being used by, say, for example, the incubator or the centrifuge, but this information goes to a holistic design or documenting history file of the equipment, as well as what the samples or or your packages has actually been exposed to. So this information is all very important. And when we look at a common theme across all of this equipment, as I mentioned previously, the 4 to 20 milliamp and dry contacts, they are pretty much across the industry a standard. Depending upon the type of device, it may be an option, but I can almost guarantee you that all laboratory equipment has one or the other available. We're going to get more into that in a minute, but I will say the 4 to 20 and the dry contacts are a primary connection point when it comes to connecting laboratory equipment with various building management systems or BMS systems, and also LIMS. So, and I bring that up because when we talk about the other types of connections, be it Wi-Fi or Bluetooth, that is not always the case. Sometimes the simplest solution is often the oldest solution, and that would be a one-to-one connection point would be a 4 to 20 milliamp. So across the board, when we look at these types of equipment, you can just imagine the massive amount of data that would be generated every single day. Not to mention all the users and the different individuals that interact with this equipment on a day-to-day basis. That's a lot of information and a lot of details happening. So where do we go with it? What do we do with it? Do we store it? Do we get rid of it? Do we even care about it? Right? What it all comes down to is what type of regulatory environment we're really playing into. What do we care about? Are we in a GMP environment or any type of good manufacturing practice environment or protocols that our quality management systems within our companies really care about? One of the most prominent questions that we get asked is, what is 21 CFR Part 11, and is it important? Well, you can see on my screen here, I've used several different resources to gather information. And let me just tell you, if you try searching 21 CFR Part 11, you will be inundated with the amount of information that you can find. I've tried to capture a few good sites on here that will provide the group as well. But this is a good layout of the different characteristics or different subsections within 21 CFR Part 11. But what is it? What does it mean? Well, at its core, or when it was first initiated by the FDA, the overall intent was something very simple, and that was to be able to replace the use of paper documents for for all data storage with that of electronic information. Excuse me. When we think about that, going from a piece of paper with physical ink, printed on it to an electronic version of information, the question of security and traceability comes into play. It's very easy to manipulate data when you're using your computer. So the basis of 21 CFR Part 11 really goes to three key questions. Is it secure? And we're going to get into detail about all three of these questions here in just a minute. But when we say, is it secure, that's not just, is the data, can it be manipulated? Or, is it generated and passed without being manipulated? It's the entire process. It's not just the data itself. It's the people that work with the data. It's those who observe, those who look at, and those who use the data to make decisions. Everyone involved, the entire system, the entire infrastructure is at play here. And understanding the end-to-end of the system is critical to answering that question of security. The next one, is it traceable, right? When we think about data, all that data being generated every minute of every day from all this different equipment, where does it go when it gets transmitted or passed from the physical equipment into the, let's say, a monitoring system, or directly into a server within your institution? Or maybe it's passed to the cloud environment for global use, right? The question is, can you trace it from point A to point B to its end location easily? And is there a discernible path in each of those points that is signed off by the individuals at each step of that process? That's what we mean by traceable. It's not just simply, does it get from point A to point B? It's how it gets from point A to point B. And the last question, is it trustworthy? This is a difficult one, because not only do we have to validate that the data that we're storing and passing and making historical records from is accurate, it's not only the data, it's also the process. We have to be able to validate the process by which we get that data, by which the data is generated. All of these things come into play in answering the questions of security, traceability, and trustworthiness. So keep these three questions in mind as we talk a little bit more about 21 CFR and how it applies to different types of systems. At its heart, there are really two types of systems at play here. One is an open system and one is a closed system. And much like it may sound, the closed system is basically one in which the users and the systems that interact with this data are all easily controlled and responsible within a, let's say, a controlled environment. And another way to look at this is the internet is a prime example of an open system. Once information is transmitted or passed outside of a closed environment and into a situation where external bodies or external persons could manipulate that data, that is what would be considered an open system. And there are safeguards and protocols that must be complied with regard to 21 CFR for each of these types of systems, whether they be open or closed. We're going to start off by talking about closed systems. Now, there are several different requirements when it comes to 21 CFR, and they actually apply to both closed and open systems. Not that closed systems are easier or more difficult to comply with, but these 11, call it criteria, would be applicable for both open and closed type of laboratory data systems. So before I jump into these different requirements and kind of expand upon each, I do want to make note of the fact when I say comply with 21 CFR versus certify with 21 CFR, there's a big difference between something being certified and something complying with. And bear in mind, there is no certification for 21 CFR. It is truly a compliance. You're not going to get a certificate from any vendor or any kind of audit body with regard to your 21 CF with complying with 21 CFR. It's a matter of proving that you do comply with these different requirements. In doing so, that would, in effect, show that your system is capable of handling electronic data at the same level of security and trustworthiness that would be accustomed with hard copy paper data. So keeping that in mind, when we walk through these different points, for example, the first one, system validation. this is not just the validation of the data that's being generated, but it's also understanding whether or not the data that is being generated is in fact valid and accurate. That can go to calibration. It can go to making sure that the data, once it's generated by the equipment or the user, is properly stored and passed amongst the different systems. It can mean a number of different things, and there is further guidance documents on this, but the validation aspect of that criteria expands the entire system and infrastructure of the data passage. That being said, all of this data that's being generated, one of the next criteria is that it be human readable. So when we talk about, for example, a serial port passing of information, right? A lot of times that would be in binary code or ones and zeros or a hexadecimal form. This information is not easily understood or really readable by humans. The intent of a record of such is to either have a key or an understanding, a cross-reference to the data if it is not a typical type of information, or it has to be a human legible, human readable, and understandable format. If it weren't, how could we validate, for example, that the data that we're seeing is in fact unaltered or accurate? So moving on to number 3, ensuring the protection of records. This goes to the storage of the information. Question being, when the data is generated at the equipment, is it immediately passed, transferred, and stored? Is it stored locally? If it is it possible that the system can overwrite or manipulate that data, right? How are we protecting that data from point A to point B? All of that goes into play. So again, we got to keep it in mind. It's the entire process that we're going to have to examine to make sure that the system is what it needs to be. And we talk about individuals. There are a lot of people that have access not only to the physical data, but the equipment by which generates the data, the systems that store the data, and the entire process. We have to be able to show a protocol or a systematic understanding of who has access, when they have access, why they have access. All of this goes into a complete authorization and audit trail, again, to protect the security and the traceability of the data that we're looking at. Along with that traceability comes the audit trails. Typically, that would require time-stamped data. So everything that is generated has a time and a date, right? Not to mention all of this data, these reports, any information that is being passed has also got to be, when it's used by individuals, electronically signed, right? Or at least the ability to sign the documents when required by your QMS protocol. That's also in play here. Kind of touched on number 6 and number 7 there. We talked about the different parts of the system that are in play, whether it be an external monitoring system versus the primary laboratory equipment. Maybe it's the computers, maybe it's the servers the data is generated on. All of that comes into the overall system hierarchy and has to be understood and checked and validated. And again, everything has documentation, whether it be the people, the data, the equipment, everything is documented. That is a very quick overview of, call it the 10 or 11 critical criteria requirements for a closed system with regard to 21 CFR, Part 11. These same criteria apply in the case of open systems. Again, open systems are more like those that use the internet or the cloud environment to store data. There are additional subsections within Part 11 that specifically call out open systems and the additional requirements that one would have to ensure to make use of such of a cloud or open environment. The major part of that comes within digital signatures and the IT security or the corporate security around the cloud environment that is being used. So it's not impossible. It is actually very, there are a lot of systems out there that do comply with the different requirements. But that begs the question, can I simply go out and buy a fully validated, I'm going to use that term loosely here, validated 21 CFR Part 11 system? The answer is no. There is no out-of-the-box validated 21 CFR solution on the market. It does not exist for the exact reason of what I just said. These systems cannot be validated and certified for the regulation. They can only claim support of. They can be in compliance of. They can help the end user, yourself, in your institution, in your lab, valid or confirm that your entire system supports the regulation or the protocol. But that in turn relies on your specific GMP or GXP environment and your QMS protocols within. Again, the systems can support, but they do not offer complete validation. If you see that, raise a red flag and ask questions, because that is not the case. In fact, if you go on to Amazon Web Services, which is the most prominent cloud-based storage center used globally, they will explicitly state that fact, that they can help support your GMP environment and provide documentation, but it is up to the end user to actually run the requirements and make sure that they comply. So that is why it's important to have conversations with your internal regulatory and quality control parties to make sure that everything is in conformance. And we can also, as Thermo Scientific, Fisher Scientific, we can also help in that regard as well. That was a mouthful, everyone. Regulatory compliance is always a very in-depth conversation. As we look now to remote monitoring systems, there are two specific types. We talked a lot about the data generation by laboratory equipment, our ULT freezers or our incubators or things of that nature that generate temperature and system alarm and event data on a continuous basis. Sometimes the systems have the ability to transmit that data from an internal or embedded system. One example would be our new Thermo Scientific TSX ultra low temperature freezers. They have that capability built within. In fact, not only do they have 4 to 20 dry contacts and serial ports, all of those common, easy to use connections, they also have built-in Wi-Fi capability. Now, before a lot of questions get raised on this one, a lot of functionality across laboratory equipment is not currently available across the globe. There are certain regulatory restrictions when it comes to telecommunications and Wi-Fi connections that differ among different regions. And for that reason, a lot of manufacturers, Thermo Fisher Scientific included, they have to approach the market in a systematic way. I will tell you right now that we are currently we're currently on the roadmap to expand our Wi-Fi based ULTs into China and APAC in the coming future. So that being said, all of this system at play, can we support 21 CFR Part 11 with our ULTs? The short answer is no. We do not have the traceability or the security built into our internal memory, our internal onboard memory of the ULT, to be able to identify and trace the required steps per the requirements of the closed systems that we just discussed. That is something that we're actively working on, but it's not available right now. That being said, there are other avenues like the 4 to 20 or serial port connections that could very well provide that information to you in a supporting 21 CFR Part 11 compliance manner. So let's change mindsets for just a minute. Those are the embedded systems. What about external systems? Those are the systems that are a bolt-on solution. These are more apt to provide a a clearer path to 21 CFR Part 11 because they are distinctly designed around that type of requirement. I say that because in most cases, this is independent monitoring. So understanding how the physical equipment is designed or the algorithms or the firmware that comes into play to generate data on the embedded systems is no longer under scrutiny when it comes to an external system like the one on the screen. We have several solutions like that at Thermo Fisher Scientific. One that this group may be familiar with is our SmartView system. It's been around for several years, and it does help support compliance with GMP and GXP environments. It does support 21 CFR, and is capable of independent monitoring of a multitude of different types of laboratory equipment. So this would be one means of a system that would be able to pass information from the initiation of data into your server, into your historical monitoring database. So that would eliminate the need for a lot of critical understanding of firmware and algorithms like the embedded systems of the ULTs, for example. We do have a lot of other or several other remote monitoring solutions available in today's portfolio, and there are actually a lot of different remote monitoring capabilities on the market today. Not all of them, again, are currently supported in the Asia Pacific region, but we are presently looking at expanding our newest SmartView Pro system, is the next generation of our legacy SmartView, to the region currently. So in the near future, that would likely become available to you. Again, it would support 21 CFR, and it would be available both on cloud and on-premise deployments, so your local server network. I bring that up because when we talk about cloud, we mentioned the fact that there are a number of other requirements that an open system or cloud-based solution would have to comply with. Well, the SmartView Pro system is one that is taking part of that into account. So we would be able to support you with documentation with regard to your regulatory needs. Now, with that, like I said, there are a lot of different solutions. It all depends on your specific GMP environment or your GXP environment, what you're looking at doing, what you want to do with the data, how it's being managed, and ultimately what your own internal protocols are asking for you to do. Not every lab has to be 21 CFR compliant, but I will tell you without a doubt, every single lab, every single individual generates data, uses data, and relies on that data to make decisions, to make calls upon their samples, historically and at the present. So maintaining a secure, traceable, and trustworthy amount of data stream is critical no matter what type of environment that you're actively playing with. So with that, guys, we've got about 30 minutes or so. We've got about 15 minutes for open Q&A. I'd be more than happy to answer any questions you may have. We'll put my video on here just so you can see I truly am a live person. But with that, we'll go ahead and open up the floor. And Boris, I'm not sure if we've got a lot of chat comments, but I'll leave it open.
Yeah. Okay. Thank you, Josh. I think thank you for your time and also your information. Remind the team if you have any questions you want to ask Josh, you can either type into the Q&A box, or you can also on your right-hand corner there is a hand symbol. Just click that, and then Jean will unmute you so that you can directly ask the question. Okay, I think the first question that I have from the floor is you mentioned that there is a lot of connectivity context of the laboratory equipment. For example, 420 mini-A, RS-232, RS-485, it's those kind of contact. And sometimes it's using Wi-Fi and Bluetooth. But in terms of customer, they have a lot of different contacts inside a laboratory. But how can they connect a system with different kinds of connectivity contacts? Is there any plans to standardize that into one solution?
It's a great question. Yeah. So unfortunately, I would say if the context of the question is specifically around Thermo Fisher Scientific and our equipment, my answer would be yes. Our aim is to provide a standardization across all of our equipment with regard to the connection types, as well as the data that you're able to pass through these different connections. To expand upon that a little bit, though, like I mentioned, in a lot of cases, the type of connection points, for example, a serial port connection, they're not just used in the transmission of data from the customer standpoint, they're also used during the manufacturing process. So depending upon where the product is being manufactured, it's likely that it may have a different type of serial port connection. That being said, there are a number of adapters and different cables that can basically harmonize that type of connection into a single output that could be used for a building management system or LIMS device or internal server. So long answer to a very simple question, Boris, but the answer is yes, we are trying to harmonize.
Will in your plan harmonize the context across all the laboratory equipment portfolio? Which method you would like to choose? For example, is this a Wi-Fi or other kind of context, physical contact, or wire contact?
Yeah, that's a tough question, and I say it's so. For ease of use, I would definitely say that the Bluetooth or the Wi-Fi connection is one that is becoming more prominent. The problem with that is depending upon the type of market or type of quality or GMP protocols or corporate security protocols that you may have, Wi-Fi is not available for all types of for all institutions. So I don't think we're going to be standardizing on a purely Wi-Fi system in any time soon, although I do see that the majority, if not all of our equipment will have Wi-Fi available. When it comes to a purely standardized connection point, I do believe that 4 to 20 milliamp and a dry contact are the only two at this point that are pretty much a standard across laboratory equipment, whether it be Thermo Fisher Scientific equipment or it be a different manufacturer. I think from what I can tell in the near future, those two types of connections are going to remain prominent.
Okay, thank you. I have another question coming from the floor is concerning about the data security of the cloud. In your presentation, you said that there will be a open and closed system for the data storage. Is there any concern about the data security you want to acknowledge and also provide the floor?
Yeah, of course. Anytime that you have an open system or one that it expands outside of your institution's IT control, there is always a question of corporate security and or security in general. With regard to our cloud environment at Thermo Fisher Scientific and really our entire solutions, all of our solutions with regard to connectivity, we have a very prescriptive and in fact, let me just pull it up, Boris. Give me 1 second. I'm going to show you.
Okay.
With corporates, hopefully you guys can, I'm going to, bear with me. I'm going to share a different application.
Yeah.
Can you
I can see that.
See the guide now? Okay. So this is a publication that we routinely update depending upon the changes within the security protocols or operations of our environment. I'm not going to spend too much time on this document, but I will make it available to anyone who wants to look at this. But effectively, this talks about the different protocols and robustness features within our infrastructure, both from a internal Thermo Fisher cloud environment as well as that of our partners with Amazon Web Services. If we look at this is the foundation, right, that all of our critical corporate security relies on. These are the different steps that we routinely administer. And we can actually walk you through the entire process and protocols from data transfer. So a lot of that discussion we had about how do you track the information being generated and passed. We can walk you through, at least from our standpoint, using Thermo Fisher Scientific based equipment and our cloud environment. We can help you make that walk to understand what is going on and what our systems do. We talk about encryption, how we use different telemetry protocols and transfer protocols, and again, the cloud protection. There's a lot of information in here, and I think it would be a great resource if you would like to read about it, and we can have a follow-on discussion for anyone that's interested. I'd be more than happy to.
Okay. Yeah, thank you. A follow-up question for that is, if the system is on cloud, how can the customer back up the system and store properly offline? Or do you have any commitment to store the data in the cloud? For example, how many years you will store in the system?
Yes. So with regard to our cloud and Thermo Fisher, the data that we store in our cloud is for life. We never get rid of it. A prime example of this would be when we store data for our ULTs or our incubators online right now. There is a download feature that you can physically take the data from the cloud and download it to your local server. I'm also presently working with our teams to develop APIs and systematic means by which systems like a BMS or a LIMS could automatically or systematically get that information from the cloud environment. We don't have that capability quite yet, but that is on our roadmap right now.
Okay, thank you. There is another question from the floor. Is this device, are they able to connect or monitor more than one kind of equipment? I believe that it is well about the connectivity solution.
Sure, and let's really expand upon a little bit about the different types of solutions and what they can do, right? So if we talk about actually, let's start with like the embedded case, right? Within the ULT freezer, the types of data that's being transmitted is all kinds. All of that information that we looked at, whether it be temperature, alarms, events, user profiles, user settings, all of that is being passed to the cloud. Okay, that's all being transmitted. It's being generated and passed. Very similarly, excuse me, the serial port connection, the RS-485 port within your laboratory equipment, it passes a majority of that information as well. So there are different types of data that can be transmitted today. If we talk about the external systems, much like the SmartView or the SmartView Pro, the question that you asked was, can it monitor different types of equipment? I think the question was really, can one piece of equipment or one SmartView monitor multiple pieces of equipment? And the answer is yes. The intent of this type of system is to be scalable, to be able to monitor an entire lab setting, not just a given piece of equipment. It may require more than one module, which is what I have on screen here. This little device, but with several of those devices and different sensors, you can monitor a multitude of different instruments. Yes.
Okay. Is there any limitation of the number of equipments that add on to the system?
No. Mm-mm.
Okay. That means it's unlimited, right?
Unlimited. Yep.
Okay. There is another question about the CR Part 11 that you mentioned quite a few times in your presentation. Uh, the question is because the US FDA CR Part 11 is not a certified body, so everyone can claim that's the CR Part 11 compliance or support CR Part 11. So how could we certify or clarify or declare the details of your system is comply or support CR Part 11?
It really comes down to an audit, right? It really doesn't matter up until that point that you're complying with 21 CFR Part 11 or not. When you start looking at quality audits of your infrastructure and you start looking at the different criterion within 21 CFR, that's when you have to show that you comply with that requirement. Like I said, there is no certification or certifying body or certificate you're going to get. It's a matter of can you prove that you comply with the intent of what the standard was derived for. Is what you're doing, is your protocol and is your QMS system actively showing that your system is trustworthy, secure, and accurate, and to enable you to use electronic information instead of paper documentation. If you can show that, you're fine. It's just a matter of being able to answer the questions being posed by an auditor and show the traceability of all your information.
Okay, thank you. I think it will be the last question that I have. That is the customer is, we have a lot of customer, like pharma customer, they would like to connect the system to their BMS or LIMS system. And right now, as you said, there was different kind of ports to connect with the system, like 4020 milli-A, RS-232, etc. So how could the customer able to connect with their BMS with our equipment? Do you have any support or any protocol standardized to help the customer to connect with their BMS systems?
That's a difficult question, Boris, because each BMS system or building management system, or LIMS for that matter, they interact with equipment differently. The real question comes down to what information are you looking to put into your building management system, whether it be temperature, alarms, or whatnot. I think if I were to say to standardize on something, I think it would have to be a 4 to 20 milliamp for a single point reading, whether that be temperature, CO2, relative humidity, whatever that measurement point is. I would use a 4 to 20 milliamp for that, because the reason I say that is because regardless of what system you're using, that is a consistent type of connection across all systems. It's simply current. All systems operate on a voltage. All systems utilize current. So that's going to be a generic form. I would couple that with the dry contact, which again operates on current. So I mean, that's the most common method, most common means. And until we have a systematic approach to download or export data from a cloud environment or the equipment directly via Wi-Fi, I think that is the most prominent and best solution for labs today.
Okay, thank you. I think that is all the questions that I have from the floor. I think right now it's already 10:50 Asia time. I think your time is already 9:50. So maybe we should end the call. Before I close this section of the webinar, I would like to special thank for the work from Shijin. She's she's spent a lot of time to set up this section and then provide the dry run and also the work behind. Also, thanks for Jeffrey Poon and also Anita. Both colleagues give me a lot of guideline and helps to be the host of today's function. And last but not least, special thanks to Joshua as the speaker, and you spend your time to prepare the presentation and also spend your time at night to provide this webinar. Remember that this webinar is recorded. If you have, if you want to reveal later on the content of this call, of this webinar, you can contact your local Thermo Scientific representative and then ask for the record of this webinar. Okay, I think that's all for today. Hopefully, we'll see you soon for the next webinar of the Cell Therapy Systems Series event. Thank you. Thank you for your time.
Thank you, everyone. Have a good day.